Hello, class. Welcome to Measures of Central Tendency and Skewness. In this brief lecture, I will remind you of the various ways to describe univariate data, and a little quick review for you. Then we will focus on the measures of central tendency, sometimes called the measures of center. And as a reminder, I've got a little asterisk next to the mean because there are multiple types of mean. Our means for this class, we will focus on just two. That's the arithmetic mean and the overall or weighted mean. Just keep in mind there's a geometric mean, harmonic mean, and a few others. And then I will work a few examples for you and talk about skewness and how skewness relates to the measures of center. So just as a reminder, these are some of the ways to describe univariate data or summarize univariate data with a single number. And we've got the measures of center. And remember, the measures of center or central tendency provide us with a single value that best describes the data as a whole. In other words, a average or a typical number. Next lecture, we'll discover or talk about the measures of dispersion. But this one will focus on the measures of central tendency and skewness and how the two relate. In the next lecture, we will do the measures of dispersion and how they're related to the measures of kurtosis or values of kurtosis that we get. So what are the common measures of central tendency? So we have the mean, weighted mean, and again, we call this the arithmetic mean. But when you're referring to the arithmetic mean, it's so commonly used that we usually just say mean. And we've got the various symbols, median and mode. And then we'll skip this part and we'll cover symmetry and how symmetry is related or skewness is related to the measures of central tendency or measures of center. And as a reminder from last lecture, these, this capital M or the MD or the MO and its italics, that's the symbol we will use that's consistent with APA format. But X bar or mu, those are the statistical symbols that you might see in a math class or a different type of journal. And this is called X bar. It's a statistic, and this is mu. It's a parameter. But the formula is identical, and these are difficult symbols to find, type. So we're just going to stick with a capital italicized M. So how do we find the mean? I've given you some basic data here, and there are no visible outliers. The reason I say that is because, as a reminder, the measures of center, the mean especially, is very sensitive to extreme values, outliers. Right? So there are sophisticated techniques, or I guess sometimes simple techniques, to determine whether or not you have an outlier. But in this case, I don't see a visible outlier. Right? And so how would we compute the mean for this? How would we compute the mean for this one? In this case, I would not use the mean. In this case, the mean is probably acceptable. So the mean requires interval or ratio data. And I put a little asterisk because sometimes we compute the mean with ordinal data. In fact, your GPA is probably computed using ordinal data, but you're safest when you have interval or ratio data and you don't have an outlier, an extreme value. In this data set, I do not visibly see any value that would be considered an outlier. But if you look at the second data set, here's what I would consider an outlier. And if we were to use a 1.5 times the interquartile range, I think this would come up as an outlier, no doubt about it. So in this case, you may be better off using a trimmed mean or defaulting back to the median. So the mean is the preferred measure of center. The reason it's the preferred measure of center is because it's the only value that takes into account all of the data. So when we compute the mean, it's sigma x, add all your data, and then divide by how much data that you have. So it does take into account those outliers. So if we have outliers, such as 20 in this case, we may want to avoid the mean and possibly consider the median, or consider maybe a trimmed mean, where you get rid of the maybe top 5 and bottom 5% of your data. So here's a simple data set. So instead of having 10 numbers, we'll just deal with 3. You can probably look at this and tell me that 90 is the mean, but how would we find that using this formula? So as a reminder, with sigma notation or summation notation, this says sum your scores and divide by how many scores you have. And so when we do that, it just says we're going to add 80, 90, and 100. And my sample size or population size, the amount of data that I have in, is 3. 1, 2, 3. So 270 divided by 3 is 90. And again, for most of my classes, I don't focus on hand computation. I would rather use SPSS or StatCrunch or Excel, something along those lines. What about the median? We're going to skip the weighted mean. So we jump from the mean to the median, and I'm going to come back to the weighted mean in just a minute. So the median has some advantages and disadvantages over the mean. It's a little bit more flexible than the mean because we can confidently use the median with ordinal data as well as interval ratio. Whereas the mean, we're typically safest with interval ratio, even though there are occasions where you can get away with ordinal data. So it's a little bit more flexible than the mean, and it's less affected by outliers. The downside is, under ideal conditions, it's not as representative as the mean. And the reason for that, when I say representative, I'm talking about taking a sample and determining how well the sample represents the population from which it was taken. And under ideal circumstances, when you have interval ratio data and you don't tend to have outliers, the mean tends to do a better job than the median or the mode. One reason for that is it takes into account all of the data. The median is only going to consider the middle number. The modes are only going to consider the most frequently occurring scores. So that's one advantage of the mean. But the median is a little bit more flexible. We can confidently use ordinal data, and it's not as affected by outliers. Now, here's the formula for the median. Problem with the formula, unlike the other formulas, is you don't actually get the correct answer. You don't actually get a value. You get a location. And so in this case, it's going to say, take your sample size, add 1, and divide by 2. And that's not going to tell you what the median is. It's going to tell you where to find the median. So it's tempting to say 100 is my median. It's the middle number. It's the 50th percentile. It's Q2. But it's not, because you have to put your data in order. Now, if you're using a program, you don't need to put your data in order. The computer will do that automatically for you when it considers what the median is. But if you're just doing this visually, make sure you put them in order. And so in this case, it's going to be 60, 70, 80, 90, 100. And you can clearly see 80 is the median. If I use my formula, I've got 1, 2, 3, 4, 5. So n is 5. So this gives me 6. 6 divided by 2 is 3. 3 is not my answer. 3 is my location. So I need a third number, which is 80. And here's this formula worked out for you. So remember, the answer is location, not the actual value at that location. So you have to remember, 3 is not your answer. I need a third number. It's 80. Some cases we have, so in this case, we have odd numbers, 1, 2, 3, 4, 5, in which case your median will be an actual number right in the middle. But in some cases, you have an even number. And in this case, you're going to have to find the mean of the middle 2 numbers. So in this case, you could probably visualize, if I put my finger right here, this is going to be the middle point. I've got 3 scores below and 3 scores above. But what I need to do is find the mean of these 2 middle scores, which is going to be 75. So if I use this formula right here, this is going to give me sample size of 6. 6 plus 1 is 7. 7 divided by 2 is 3.5, so I need the 3.5th number. It doesn't exist in this actual data set. It's just the mean of these 2 numbers. What about the mode? The mode is probably the least used, but it's also the most flexible. In fact, it's the only measure of center you can use if you have nominal data. So that's why I put nominal ordinal interval ratio. If you have nominal data, you're stuck with the mode. So it's probably, under most circumstances, the least representative, whereas we said the mean is probably the most representative. But it does have some advantages. One, you can get away with nominal data, and it's the least affected by outliers. The mode doesn't really have a formula. It's just a matter of observation. And so there are occasions where you will have no mode. There are occasions where you may have a single mode, and there are occasions where you may have multiple modes. So in this case, there is no mode. I don't see one number that occurs more frequently than any other value. In this case, I just simply threw a 60 on there, so now I've got two 60s, so my mode would be 60. And if I added a 70, I've got two 70s and two 60s, so in this case, I have multiple modes. Let's go back to the weighted mean then. So the weighted mean, sometimes called the overall mean, it's still a mean, but it's very useful when your groups have unequal weights. And so you probably encounter this most often in your class or your GPA in college. And so, for example, in this case, exam 1 is only worth 30%, and exam 2 is worth 70%. So if you just added up your two scores, 100 and 150, or 50, you get 150 divided by 2. If you just use the arithmetic mean formula, you would come up with a mean of 75. But we know that's not the case. We know that's a problem because exam 2 is worth twice, more than twice what exam 1 is worth, and you did poorly on exam 1 or exam 2. Exam 1, you made 100, so we know it's not going to be 75. It's going to be closer to the 50 than it is the 100. So what we do is we got to use this formula. This formula simply says take each score and multiply it by its weight, then divide by the sum of your weights. In this case, sum of the weights are going to be 100%. So I'm going to take my first score, which was 100. I will multiply it by its weight of 30%. And then sigma tells me I'm going to add. I'm going to take my next score, which is 50, and I'm going to multiply it by its weight, which is 70%. So that gives me 3,000, and 3,500 divided by 100 is 65. Let's do another one. So in this case, we're looking at your GPA for the term of the semester, and you've taken 3 courses. You made an A or a 4.0 in a 4-hour class. You made a B, or you got 3 credits for a 3-hour class. Then you made a D, which is only worth 1 in a 2-hour class. So I'm going to take my 4.0 and multiply it by its weight. Then I'm going to sum. I'm going to take my 3.0, multiply its weight, 3 hours. And then course 3, I only got a D, so I only get 1 hour credit, or 1 credit. And I'm going to multiply that by 2, because it's a 2-hour class. And so 4 times 4 is 16. 3 times 3 is 9. And 1 times 2 is 2. And how many hours did you take for the term or the semester? 4, 5, 6, 7, 8, 9. And so that's the sum of my weights right there. So in this case, you would have a 3.0 for the term. All right, so those are the 4 most common measures of central tendency. Next time we'll talk about the measures of spread, but I want to briefly talk about how the measures of skewness are related to the measures of central tendency. And so this is not my diagram. Give credit when credit's due. I got this from biologyforlife.com. So here's a ideal bell curve. It's perfectly symmetrical. There's no outliers, no dominant tail. When you have a perfectly symmetrical distribution, in this case, the bell curve, the normal distribution, the mean, median, and mode are identical. So if you know the mean IQ is 100, because IQ is normally distributed, you also know the median IQ is 100. You also know the modal IQ is 100. But take a look what happens when we start to get outliers, extreme values. Extreme values would pull the tail to the left, which would be called negatively skewed, or it could pull the tail to the right, which would be called positively skewed or right skewed. And when this happens, the mean gets pulled furthest in the tail. It's closest to that outlier. So in a positively skewed distribution, the mean is going to be the largest measure of center. It's going to be greater typically than the median or the mode. And if it's a negatively skewed distribution, because that mean is sigma x over n, because it picks up on all the scores, it's going to be the first to pick up on that outlier. And so if you have a outlier that's smaller relative to the rest of the data, the mean is going to take that into account, and it's going to be smaller than the median or the mode. And if you have a positive outlier, or not necessarily positive, but a outlier that is larger relative to the rest of the data, then you're going to find the mean as the largest measure of center. It's going to be pulled to the right. And so we said we like the mean, it tends to be the most representative, but there are occasions when we don't like it. And if we have extreme outliers, the mean can be a problem. So if you had Bill Gates or Donald Trump or Jeff Bezos in your sample of income, that one billionaire could greatly skew income for the rest of the people, and you might end up with an average mean income of $2 million, we know is ridiculous. So under ideal circumstances, the mean is the one we want to use. It takes into account all the data. It tends to be the most representative. But if we have skewness, the more skewness we have, typically because of an outlier, the mean is going to get pulled the furthest. And so we have to be careful in those circumstances. So let's do a few practice questions. The mean is the most commonly used measure. By far, it's the most commonly used. Just like the standard deviation, when we get to it, is the most commonly used measure of dispersion. The mean is by far the most commonly used measure of center. And the reason for that is because it tends to do the best job in a sample of representing the population from which it was taken. It's the most democratic. It takes into account all of the data. It is possible for a data set to have multiple means. It is not. You can break the data set up into subgroups and then find multiple means. But for a single data set by itself, you only have one mean and you only have one median. And the purpose of this question is to let you know that in some cases, you may actually have multiple modes, though, or no mode. So you always have one mean, you always have one median, but you can have no mode, one mode, or multiple modes. So this is false. It's not possible. In a positively skewed distribution, the mean is typically the largest. That is true. So when you have a positively skewed distribution, the tail is going way over here in an exaggerated example, which means the mean is going to get pulled to the right, and it's going to be larger than the median in the mode. So that's true. It is possible for a data set to have multiple modes. So unlike multiple means, which was false, multiple modes are possible. So that is true. The mode is the least affected by outliers. So typically that is true. So if you go back to the distribution here, you will see the mode typically is the least affected by these outliers, with the mean being the most affected. The mode can be found with any type of data, so that's a nice advantage of the mode. Besides being least affected by outliers, you can use it with nominal data. You can't find a median or a mean with nominal data. So this is true. The mean can be found with any type of data. That's false. Typically, we like to have interval or ratio. If we're confident in our ordinal scale, then we can also use the mean, but it cannot be used with nominal data, nor can the median. That's false. The mean takes into account all of the data. It's sigma x over n. Add up all your data and divide by n. That's why we like the mean. That's the factor or the characteristic that makes it the most representative, unless you have an outlier. So that's true. The median is always the 50th percentile, and it's the very definition of the median. It's the middle point. It's the 50th percentile. It's Q2 or the second quartile. Sometimes the mean is the 50th percentile. Sometimes the mode could be the 50th percentile, but that's not the definition of either of those. The median is always the 50th percentile. You probably look at this and tell me what the mean is. You add all three up and you divide by 3. That's going to give me 18 divided by 3. 6 is the correct answer. The mean for 2, 4, and 6, or 2, 6, and 4 is not 6. When I add these up, I get 4 and 6 is 10, plus 2 is 12. 12 divided by 3 is 4, so that's false. The mode, we don't have a mode. The mode is the most frequently occurring score of scores. I don't see one that stands out, so that's false. These are all possible symbols for the mean. So capital italicized M, X bar, which would be a statistic, and mu, which would be a parameter. Same formula for all. We can use all three. I will typically focus on this because it's the easiest and it's what APA recommends. So that's true. The median requires interval or ratio data. That is false. You can get away with ordinal data. The mean typically requires interval or ratio. The median, however, is a little bit more flexible, so we can go down to ordinal data. So false. That's it. As always, guys, feel free to text, email, call 7 days a week.